In this lesson, we're going to talk about how to solve problems that have three triangles. So we can also use our trig ratios and our Pythagorean theorem to solve for triangles that might be within 3D shapes. So if you look at example 1, it says Alexis has a can of soda that has a height of 15 centimeters and a diameter of 8 centimeters. What is the longest length straw that will fit diagonally in her soda? So here, the height of this cylinder, can, is 15. And the diameter, so remember that's the measure straight across the bottom or top, is 8. So we're looking to see how long of a straw she could fit diagonally through this can of soda. So putting it in right at the edge and all the way down to the bottom. So if you notice here, we've got two measurements. This would form a 90-degree triangle, so we could use Pythagorean theorem to solve for that length. We'll call it x. So remember, actually, we do the two legs, so 8 squared plus 15 squared will equal x squared. So 64 plus 225 will equal x squared, which is 289. And then the last step is to take the square root of 289, which is 17. So the longest straw that could fit diagonally in the can is 17 centimeters long. If we look at example 2, it says Renan works in the Langara Point lighthouse. The top of the lighthouse is 160 feet above sea level. She sees a boat in distress at point D and a Coast Guard boat at point C. How far apart are these two boats? So we're looking for this length here. What you'll notice is we've actually formed three triangles. We have one triangle that goes out to boat C, one triangle that goes from the line of sight out to point or boat D, and then we've got this triangle that's formed between them. So what we need to do, if we need to solve for Z, if you look in this lower triangle, there's no information there. We have no angles and we don't know any side lengths. But in these two smaller triangles, we know 160 feet and we know the angle 38 and the angle 24. So I'm going to use this angle and this height to solve for x, and then I'm going to use this angle and this height to solve for y. Once I know two sides of this triangle, I can solve for z. So let's start with x. So in this triangle, we have our opposite and our adjacent. So that means tan 38 will equal 160 over x. So x equals 160 over tan 38. 204.8. And this is in feet. So that's the length of x. Now we're going to do the same thing to find y. So tan 24 is 160 over y. And 60 over tan 24. Y is 359.4 feet. And so now we know that this is 204.8 and this is 359.4, and this is a right triangle. So again, we could use Pythagorean theorem to solve for z. So 204.8 squared plus 359.4 squared will be equal to z squared. 171,111.4 is z squared, and then I'm just going to take the square root of that. And I get 413.7. That's the length of z. That's how far apart the two boats are. If we look at example 3, it's asking you to find the length of AH. So that is this length here. So it's from this top corner down to this bottom corner. That's the length that we're looking for. Now again, this triangle itself here, which is kind of like a slice right through this rectangular prism, we don't know anything about it. We don't know the height, we don't know this diagonal, we don't know any information. But we could use the other information we have here to solve. So if you look at the bottom, we've got 11 and 6, and then we've got this diagonal through the bottom. If you picture the bottom of a rectangle or a rectangular prism, we've got 6 and 11, and then we've got this diagonal through the bottom. Well, we could solve for this using Pythagorean theorem. Oops, sorry. Using Pythagorean theorem. So I'm going to solve for x using Pythagorean theorem. So 11 squared, 11 squared plus 6 squared will be equal to x squared. So 121 plus 36 equal to x squared, 157. And then I take the square root of that, that's 12.5. And this is centimeters. So that means this here is 12.5. Well, now if we look at this triangle, AH is the hypotenuse, and this 12.5 is the adjacent in relation to this angle of 27. So now I could use cosine of 27 is equal to 12.5 over the hypotenuse. The hypotenuse then would be 12.5 over cos 27, which is 14, we'll just call it 14 centimeters. So that's actually the length, AH, or the hypotenuse in this triangle. Finally, we can also use triangles like this to solve for angles. So this is asking you for, oh, I should mention, a plane is the flat surface formed between points. So this says determine the angle between SV, so here's SV, and the plane RSTU. So it means basically the angle between this line and RSTU is the rectangle on the top. So we're looking for, it's tricky to draw this, we're looking for the angle up here. Now what makes this angle a little bit easier to see is if we can form a triangle in here. So I'm going to form a triangle by drawing a diagonal line on this plane, so on this RSTU. So that can kind of be helpful to see there. So then if I'm going to make this angle a little bit more accurate. So here's this line that runs from S to U. It's on the top of this rectangular prism. And we're looking for the angle between that plane or that top and SV, this line. So that makes it just a little bit easier to see. So here's the triangle that I'm ultimately looking to work with here. So in this triangle, I know the height of this rectangular prism is 5. I don't know the length of this diagonal, and I don't know the length of SV. But if you look, I do know on the bottom, this rectangle is 11 by 6. 11 by 6, which is actually the same as on the last page. So here, I could find the diagonal. By finding that diagonal, so here's my rectangle on the bottom, that's 11 by 6. It means the rectangle on the top is also 11 by 6. So the diagonal here is this one. So 11 squared plus 6 squared is equal to, let's call it x. So 121 plus 36, so that's 157. And we just did that on the previous page. It was 12.5. So this diagonal is 12.5. So basically here we have a triangle. I could redraw it. That's 5 by 12.5. And we're looking for this unknown angle. So here we've got the opposite and the adjacent. So tan of the unknown angle is 5 over 12.5. So that angle will be tan inverse of 5 over 12.5. Which is 21.8 degrees. So when it comes to these questions that have multiple triangles, sometimes it can be helpful to draw your shapes outside of the larger shape just to sort of organize your information. But from there, you can still use SOHCAHTOA, you can use Pythagorean Theorem.